Okay, ladies and gentlemen, we need to talk about a couple of questions in your homework, but I'm going to focus mainly, well, okay, we're going to talk about page 47, number 12. Now, I know all of you did it and all of you think you got it right and it's wonderful, but chances are you haven't really satisfied the question. So the question is saying show, first of all. That's a very important thing in mathematics. It means that we're going to have to do a left hand, right hand, and we can't manipulate across the equal sign. And it's going to want us to show, and it goes even farther, using the properties of limits. Now, when they say that you're going to use the properties of limits, what they really mean is everything up to and not including the mega property. So pretty much all of the fundamental properties of limits we're allowed to use, but the mega property is not one that we're really allowed to use. So straight substitution isn't going to be an option here. In this question, they're going to let us have the limit as x approaches 3, and they're going to tell us that it equals 3. Oh, I think it's 5 down here. I think I wrote that wrong. Let's see. Let me check. Yeah, it's 5. So this equals 3. So the limit as x approaches 5 of f of x equals 3. And then they want us to show that if this is true, then the, looking over there, limit as x approaches 5 of x squared over 4 over top of f of x equals 7. So probably most of you, and I would have too, absolutely, you probably went along and said, okay, the limit is x, I'm going to put in 3 in here, and I'm going to put in 3 in here, and you're going to get 7. And, well, no. First of all, we have to do it using the properties of limits, which means that we really can't evaluate anything until we get it down to something like this. This is the most fundamental property of limits for evaluating an x term. We're going to have to get it down to that to be able to say that as x approaches k, therefore, if I have the function x, it's approaching k. And that just is a fundamental truism. You and I agree that's what that means. The mega property is going beyond that. It's putting all the properties together. The other property I'm going to be allowed to use is this one, that if I'm going to be using a constant and as x approaches k, that's only going to be a constant. That's one of the properties I'm going to be able to use. Now, another property that I'm going to be able to use is the limit as x approaches k of a sum or difference is equal to the limit as x approaches k of the sum or difference of the limits. And that's very different. And talking to the class that I had in here today, they weren't really making that connection, that this is the limit of a sum, and this is the sum of two limits. So the limit of a sum or a difference is equal to the difference or the sum of the limits. That's very, very different. And we have another one. So we have the limit as x approaches k of, if I have a constant value times an f of x, we know that that's going to equal the constant value times the limit of f of x. And we can prove that one. That one's going a little outside, but if we look at the limit as x approaches k of maybe f of x plus f of x, okay, then we know that that is going to be the limit as x approaches k of f of x plus limit as x approaches k of f of x. So the limit of a sum is equal to the sum of the limits, and we know that this could be rewritten as, I've got two things being added together. So in mathematics we say 2 times those two things, and in here we have two things being added together. We have the limit as x approaches k of 2 times those things being multiplied together. So this is just a clarification or an example that the limit of a constant times a function is equal to the constant times the limit of the function. So, okay, I've made my point. We're going to have to use these properties only and not the mega properties. So let's go back to the question. Here's the question. So to actually answer this as a show, you're going to want to have a left-hand side and a right-hand side. The left-hand side is this one. That's the left-hand side of this guy. And the right-hand side is this one. So here's your right-hand side. Here's your left-hand side. And for a show, you don't want to be crossing over the equal sign. For a show, you want to be able to do all your work here and show that it actually equals the other side. And kind of like when you were doing your trig identities. The only piece of information that they're giving us, other than the property of the limits, is this. So somehow I got to change this so that I get this f of x and this limit side by each, so that they're one thing, and then I can make it 3. But before that, I can't. So the first thing I'm going to do is I'm going to notice that this is the limit of a quotient. So that's going to equal the quotient of the limits. And that's using my first limit property. So the limit of a quotient is equal to the quotient of the limits. Second limit property is the limit of a difference is going to equal the difference of the limits. This one, the limit of a power is going to equal the power of the limit. Now I could have gotten rid of some of this other stuff as we've been going on, but I just thought I'd do it all at once. But certainly, we know this using the property of limits. This is the limit as x approaches k of a constant. Well, that's going to be 4. The limit as x approaches 5 of x is 5. And this one is the one that they gave us, so it's not a limit property. We look back up, we know the limit as x approaches 5 of f of x is 3. So we get 3 on the bottom. And I should have equal signs going all the way down. And so what I get is 25 minus 4 over 3, 21 over 3, unless I've made a mistake somewhere. Okay? And 21 over 3 is 7. And so look, my right-hand side is 7, my left-hand side is 7. Therefore, I have shown that left-hand side equals right-hand side. That's familiar of the checks that you used to do in grade 9 and 10 with linear functions. And so what you've actually shown is that the limit as x approaches 5 of x squared minus 4 over f of x equals 7. Okay, guys, that's that one, and I'll be right back, and I want to do one more example with you.